today's video, let's discuss about two algorithms which related to selection problem, which involves finding the i's smallest element in a list. So let's try to illustrate difference between the randomized select algorithm and the quicksort. So specifically, we're focusing on the partitioning strategy and runtime behavior. So let's say we try to find the third smallest element. Suppose we have an array A which contains the elements 7, 2, 1, 6, 8, 5, 3, and 4. And first we do quicksort. We would sort the entire array to find the i's smallest element. First we do partition. We choose a pivot. Let's say we pick 4, and then we rearrange this array. So the elements less than the pivot come before it, and elements greater than it come after it. So we get 2, 1, 3, 4, and 7, 8, 5, 6. And then we recursively sort both sides. We sort both the left side 2, 1, 3, and the right side 7, 8, 5, 6. So the complete sorting of this array we get is 1, 2, 3, 4, 5, 6, 7, 8. And the third smallest element is 3. So this recursive sort of both partition is where the quicksort consumes more time. Typically, it is O of n log n on average due to the multiple level of recursive sorting. But the randomized select focuses only on finding the i's smallest element, not sorting the entire arrays. So it's partition, similar to quicksort, which is also just choose the random pivot and partition. So let's randomly choose the pivot 4 again, which we get 2, 1, 3, 4, 7, 8, 5, 6. And then we recursive focus, since we are looking for just for the third smallest, which is I is equals 3. So our pivot 4 is at the position 4. And we only need to focus on the left partition, which is 2, 1, 3. And there's no need to sort or process the right side, which is 7, 8, 5, 6, since the third smallest cannot be in there, right? Because randomized select focuses only on one partition per recursion, it skips unnecessary work, which yielding an average runtime of O of n time. And if the pivot randomly ends up exactly where the ith element should be earlier in this algorithm, then there's very few recursions are required. So the quicksort processes both partition regardless of ith position sort, while the randomized select processes only the relevant partition. So the quicksort works on O of n log n time complexity due to the full array sorting, while the randomized select benefits from O of n average complexity by focusing efforts only where necessary. So just by using a selection strategy that focuses only on relevant portion of this array, randomized select optimizes this process to find the specific order statistical more efficiently than sorting the entire array as quicksort does, right? And then let's talk about the randomized select algorithm, which provides a way to find the i's smallest element in an array. So let's try to walk through this algorithm by using an example to illustrate how it works step by step. And our objective is to find the third smallest element in the array A. Let's consider if we have an array A which contains elements 8, 4, 2, 10, 6, 7, 1, and 3. So the initial call is the randomized select A, 0, 7, and 3. So P is equal to 0, which is our start index, and I is 7, which is our end index, and I is equal to 3. That means we are looking for the third smallest element. And we run the randomized partition. Let's assume the randomized partition picks 6. So as our pivotal and arranges this array as 4, 2, 1, 3, 6, 8, 7, and 10. So the pivotal 6 is now at the index Q, which is equals 4, and K is equals Q minus P plus 1, which is 4 minus 0 plus 1, which is 5. That is mean 6 is the fifth smallest element in this subarray. Now let's do the recursive decision. So I is 3, which is less than K, which is 5, which indicating that the third smallest in the left partition. And then now new called randomized select A033, and we're focusing on 4, 2, 1, and 3. And then the second level call let's assume the randomized partition will pick 2 as our pivotal this time, which we get 1, 2, 4, and 3. So the pivotal 2 is at the index 1, q is equals 1, and k is equals q minus p plus 1, which is equals 1 minus 0 plus 1, which is 2. That means the element 2 is the second smallest element in this subarray. And now let's do the further recursive call. I is 3, which is greater than k, which is 2. So we look in the right partition of the current subarray. We do the new call, RANDOMIZED-SELECT A, 2, 3, and 3 minus 1, which we get the random select A, 2, 3, and 1. So now let's just focusing on 4 and 3 to find the first smallest in this subarray. So the final step, we assume the randomized partition, which we choose 3, which we get 3 and 4. So the pivotal 3 is the index q is 2, and k is equals q minus p plus 1, which is 2 minus 2 plus 1, which we get 1. That means 3 is the first smallest in the 3 and 4 this subarray, and since I is equals 1, it matches k, right? So we just return a at q, which is a at 2, which is 3. So the third smallest element in this array A is 3. This example showcases how the randomized-select effectively narrows down this search space by focusing only on the relevant partition, which reduces the average runtime compared to sorting the whole array.